The application that we're going to build is a CRM application. It'll feature a login page using Spring Security so that we can authenticate users. It'll have a list view where we can list contacts in our system and edit and delete them. You can also filter them like this. It also has a dashboard view where you can see the stats of the contacts in our system. And finally, we're going to turn this into a PWA so that you can install this on your desktop or device. We're also going to walk through production deployment, so how we can take this application, change it to use a Postgres database, and deploy it to Heroku so that we can share the link with anyone else. Now, you can find the text version of this tutorial on vaadin.com under docs, and be sure to go to version 21 or later. There are some subtle differences between 14 and 21. I'm going to go through the 21 and later version here. If you're on Vaadin 14, you can change the version here and follow the tutorial for that version. I'll add a link to the text version of the tutorial and the source code in the description below. If you have any kind of questions or problems, you run into issues while you're working on the project, please join us on the Vaadin Discord. I'll also add a link to that in the description below. And there you can chat with the Vaadin community, and they can usually help you figure out what's not working in your project. So with that out of the way, let's create a new project and get going. All right, so the first thing we need to do is download a project starter. For that, either use the text version of the tutorial and go to the project setup chapter and click on download starter, or I will also add a link in the show notes below. This will download a zip file that you should extract, and typically it's good to move that out of your download folder just so you have it somewhere safe and you don't accidentally delete it. The next thing we need to do is open that up in a IDE. I'm going to use IntelliJ throughout this tutorial, but if you're more familiar with another IDE, you can go ahead and use that instead. So I'll open the project by navigating to the desktop, selecting the folder, and clicking open. All right, so we'll give this just a minute to load all the dependencies that it needs, and then we'll take a look at what we have. All right, so let's open up the project and just take a peek at the POM file, which is the Maven project file. So what we'll see is that we have a Spring Boot project using Vaadin 21 in our case. And if we look at the other dependencies that we have here, you'll see that we have a H2 database, so that gives us an in-memory database that we can use throughout the development cycle here. We're going to configure a Postgres database when we go to production, but for now we're going to use just the in-memory H2 for easy development. We also have Spring Boot JPA for accessing the database, and we have Spring Boot DevTools so that we have live reload as we're coding. Then if we take a look at the code here in our Java folder, we'll see that we have an application class here, which is the Spring Boot application. And this is what we can launch here to run the application. So in IntelliJ, you can go ahead and click on the run button here. You could right click on the application itself and select run on this. So you could select run here. Or then you could use the Maven default command Spring Boot run in order to run it through the command line if you prefer to do that. Now, while that's starting up, we can take a look at the views that we have here. So right now, as we're starting, we have a single view. So we have a view that is mapped to an empty route, extending vertical layout, displaying an image, an H2, so a heading level 2, and a paragraph of text all being centered. The first time you run the application, it will take a couple of minutes because the Vaadin build tool will go ahead and download all the Maven dependencies that are needed, all the front-end dependencies that are needed through npm, and then it's going to build the front end assets. All of this happens once the first time you run the application, so it'll take a while, but fortunately it's not something you have to do every single time you start the application. So you can see the front end compilation is starting now. This might take anywhere from a few seconds to a few minutes, depending on your internet connection and your computer, how fast it is. And while that's going on, we can kind of start sorting out our workspace so we have enough room here to work with. All right, so we can see now we have the initial view here, visible, mapping to this list view here that we have. Now, one thing to note when you start the application is that, especially with IntelliJ, it will start performing an indexing, and this will take quite a while on some computers especially. So this might take anywhere from say 10-15 seconds to even a couple of minutes. While this indexing is going on, your kind of experience will be a little bit limited in that it won't autocomplete and things like that won't work. So we'll wait for the indexing to finish, and then we'll make a small change to the application and make sure that the live reload works the way it's supposed to. All right, so the indexing is finished, and let's just make sure live reload works. So I'll remove all the code I had here. I'll type add, so I'm going to add something to the layout, create a new H1, and type in the classic hello world greeting here. To get live reload to work, I need to build a project. So depending on your IDE, it might be enough for you to save the file, or in IntelliJ you need to actually build it. So it's either Command or Control F9 or press the hammer icon here. What'll happen then is Vaadin will notice that something has changed, and it will reload it, and you can see that we have the application changes now visible here. All right, so before we start building anything, let's take a quick look at what Vaadin is and how it works. Close the download window here and go back to the documentation here under Design System. So Vaadin is a component-based framework, meaning that we have a whole big library of these ready to use building blocks that we can use. Anything from input fields to combo boxes, date pickers, number fields, so on. We can use all of these by initializing new components. So for instance, we could do a new button, give it a caption like click me, and we can then add this to the layout. So, well, first of all, we could extract this into a variable. We could call it button, and we can then, when we're inside of a layout, we can call add to actually display a component. And in this case, we can display the button like this. And what will happen then is that it will show up here in our view. Take a while to reload, and once it reloads, you can see we have a button here. Now, layouts are what determine how things get displayed. So if we were to add another thing here, so let's create a new text field here for capturing the name. And we'll have, this can be called name. Let's add name here to our layout and see how that works out. All right, so again, we'll wait for the live reload to kick in, and we'll see that we now have the name and the button on top of each other here. They're on top of each other because they're inside of a vertical layout. So if we wanted to instead have them next to each other, we could instead create a new horizontal layout and add those to that instead. So we could add those to a horizontal layout. Let's call this HL for now, and we'll instead add that here to our main layout. And again, we'll wait for this to reload real quick here. And you'll see that they're now next to each other. Obviously, what you're also seeing is that they're not quite aligned the way you would hope them to be, because they're both aligned to the top of this horizontal layout. So what you can do then is define how things should be aligned here. So you can set, for instance, the default vertical alignment to, in our case, baseline is a good alignment. So aligning the baseline of the text of both components, that will make it look kind of visually appealing. All right, so now we have the two components next to each other aligned properly. The final part of kind of how Vaadin works is to add functionality by adding listeners. So on our button, we can add a click listener. So whenever this button gets clicked, we can decide what we want to do. So here we could do, for instance, we could show a notification. So we'll actually need to be careful to pull in the right notification, so not the JavaX management one. So we'll pull in the Vaadin Flow component here, say show, and what we'll say is then hello, and we can get the name from the name field, get value, like that. All right, so now we've created some components, we've laid them out using layouts, and we've added some functionality by adding a listener for an event. So let's save this and make sure that it works. All right, waiting for the reload to kick in. And then I'll type in my name, click the button, and you can see we get a notification saying, hello, Marcus. So those are the basics of working with Vaadin. Everything is a component, so we can create components by instantiating Java classes. We lay out components by putting them into layouts like horizontal layout and vertical layout. And finally, we add interaction by listening for user events and reacting to them. All right, so now that you know some of the basics of building a Vaadin application, let's start building out the first view. So we'll go back to the tutorial and go to the creating a view chapter here. And what we're going to focus on here in the first part of the tutorial is building out just this context list view. So we're going to get to the wrapping view here with the navigation bar and everything in a little while, but we'll just focus on building out this view here. So we'll have a text field, we'll have a button, and we'll have a grid containing contacts. And if you're following along, it might be easier for you to just go and copy the code from here instead of trying to code along, but I'll let you do whatever you feel is better for you. All right, so let's go into our app here, and I'll close the sidebar just so we have more space for the code here. We'll begin by just removing all of the code we have here, and then we'll start working from the top down. So page title is what's going to be the page title in the browser. For this particular page, it's going to be the contacts list. So we're going to call this contacts, and then we'll have a pipe and just say Vaadin CRM, which will be the application name. The route annotation means that this view is mapped to the route, the empty route, so essentially to the context route. All right, so with that, we're ready to start creating the components that we need. And as you may remember, we'll need a grid and a text field. All right, so the first thing we'll create is that grid. So we'll have a grid that's going to hold contacts. We'll call this grid, and this will be a new grid, and we'll pass in contact.class here as the parameter, so the grid knows what kind of objects we'll be working with. The other thing we need is a text field. So we'll create a new text field. We'll call this filter text, so we know what we have in there, and we initialize this to a new text field, like that. All right, so then we get to the constructor, and this is kind of where we bootstrap our view, where we start creating things. First thing I'll do, and what I like to do when I'm creating a new view, is calling add class name and giving this a CSS class name, just so if I end up writing CSS later on, it's going to make things a whole lot easier. So we'll call this list view. All right. Then we're going to call set size full, which will make this view the same size as the entire browser window, because that way we can have that data grid reach all the way to the bottom. By default, a vertical layout would only be as tall as the components inside of it. So that would leave some unused space at the bottom, which is not what we want to do. Then I'm going to call a new method, configureGrid, to actually split out the configuration of this grid. And the way I like to do that is just type out the method name, use the ID to generate the actual method. So what are the things we need to configure in this grid? Well, first of all, I also like to add a class name for this grid so I can style it later. So we'll call it content grid. Then I'm going to call set size full on this grid as well. That way it's going to take up all the space that's available to it. Next, we're going to configure the columns that we want to show. So let's take a look at the contact class here. And if you open up the sidebar here, you'll see that the starter that we started with has a data directory here, which contains our entity classes. So we have a contact, which is what we're looking at here, contains a first name, a last name, a company, a status, and an email. The company contains a name and a list of employees belonging to that company, and the status is simply a name. So in this case, the status of a contact might be something like closed lost or closed won or similar to that. All right, so anyway, in this case, we have the fields first name, last name, company, status, and email. So when we start configuring the grid here, we can tell it which columns we want to be showing. By default, it would be showing all the grids just as they are, but we want to configure them a little bit. So I'll call grid and set columns, and this will take in strings for the column name. So I'll say first name, last name, and email. I'll close that again. Now, those are the primitive columns that we'd had in there, but we had a couple of columns that contained objects, and if we just call set columns like this, those would be just printed as whatever that object to string is, and that may or may not be what you want to do. So what we can do instead of just setting the columns like this is define a custom column. So we can call grid, and we can call add column. And what it will take in essentially is a lambda that takes in the contact and should return a string then that we want to display for that column. So in this case, we're going to do contact.getCompany.getName to get the company name. And then we're going to call setHeader company. So that way we have a column showing the company by getting its name. We'll do the same for the status. So we'll call grid.addColumn, and we have the contact. We call contact.getStatus.getName, and then we'll set the header to be status like this. Actually going to reorder these so we have the status before the company. And the last thing I want to do for configuring the grid is making sure that all the columns get automatically resized to a proper width. We can do that pretty easily by calling grid and calling get columns to get all the columns, and then for each of those columns, what we can do is call column.setAutoWidth to true, like that. So that way we have configured the grid columns that we want to show, and then making sure that all of them will be properly sized to fit the content inside of them. All right, so that takes care of the grid. And if you remember, we're inside of a vertical layout, which means that anything we add to this layout will be placed on top of each other. So what we're going to do is we're going to call add and have two things. One will be the toolbar with the filter field, and the second one will be the grid For the filter field, I'm going to again split this into a separate method just to kind of keep the constructor nice and small and kind of easy to understand. So we'll call get toolbar for getting that, and then we'll pass in the grid as the second component. First, we need to, again, generate this method, and this method should return the component that we want to return for the toolbar. So for the toolbar, let's first of all configure this text field that we have. So we'll call filter text.set placeholder, and the placeholder text we want to be shown there is filter by name. Then we're going to set the clear button visibility to true. So that way, if there's something written in the text field, somebody can just click on the clear button and clear all of that out. We're also going to optimize this a little bit by setting the value change mode to lazy. So what this essentially means is that a little bit later in the tutorial, when we start actually implementing the filtering, we don't want to actually hit the database on every single keystroke. We want to kind of wait for the user to stop typing for a little while so that we don't unnecessarily keep fetching everything from the database on every keystroke. All right, so that takes care of sorting out the filtering text field. The other thing we need there is a button for adding new contacts. So we'll create a new button, and the text here will be just add contact. And I'll extract this into a variable, and the added variable can just be like add contact. Let's say add contact button like this. And then, because we want these two components to be next to each other, we need a horizontal layout to wrap those. So I will create a new horizontal layout, pass in the filter text field and the add contact button. I'll extract this into a toolbar variable, and then I'll take the toolbar, add a class name to this because I need it for CSS later. So we'll call this toolbar. And then finally, we will return this one toolbar. All right, so if we look at what's happening now is that when a user navigates to the context root of the application, this view will get initialized. It's a vertical layout, so everything inside of it will be displayed on top of each other. We make the layout full size, we configure the grid columns, and then finally we add two components to the grid. We get the toolbar component, which is a horizontal layout with the text field and the button, and then the grid is the second component here. Again, let's build this and take a look at what we get in the browser to make sure that we're on the right track. Again, we'll wait for the reload to finish. And what we should see right now is that we have the filter toolbar up here, and we have an empty grid here. The way we'll approach this is that we'll create all the UI components we need for this view first, and then we'll start looking at creating the backend implementation that we need for actually populating and updating and saving and all of that. All right, so the next thing we're going to do is create the editor for the individual contact. So in the text version, we're going to go to the next chapter, and you can see that we're working on this part of the application right now. So the form where you can see and edit contact details. Again, if you're following the text version, you can copy the entire code, but I'll walk you through the implementation in the IDE. So what we're going to do is open up the sidebar here and navigate into the list view package here. And we're going to create a new component. We create a new component by creating a new Java class, and I'm going to call this contact form because it's a form for editing contacts. And I'm going to add this to my Git. All right, so contact form will extend not from vertical layout or horizontal layout, but from form layout, which is a layout in Vaadin that's suited for creating forms. It will responsively either have one or two columns depending on how wide your viewport is. Creating these own components is something that's very common when you're building Vaadin applications. So you can build compositions of existing components and essentially create your own custom components that you can use in the application. So in the case of our form, what we'll do is we'll create input fields for all the properties of our contact, and then we'll display them in this form layout, and we'll add some buttons for things like saving, deleting, and closing. All right, so I'll just start from the top, create a text field for first name, and this will be a new text field, first name. We'll create another text field for last name, and that'll be also a new text field, last name. Then we'll create an email field called email, and that will map to a new email field. So you can kind of see these field names map pretty much one-to-one to the underlying contact object, and we're going to get to that in a moment. So we'll give this a caption of email. Then what we'll need for the status and the company are essentially like these drop-down selects. For that, I'm going to use a combo box. And the combo box type will be a status for the status select. And here, again, we want to make sure we get the right status, so the one in our application. And this will be a new combo box status. And finally, a combo box for the company. It's equal to a new combo box for company, like this. All right. So like I kind of hinted earlier, there's a reason why I named these exactly the way I did. And that is if we look at the contact entity that we're binding to, if these have the same names as our entity below, we're going to be able to use the Vaadin binder later to tie those together automatically. All right, so now that we have the fields created here, let's create a new constructor for the contact form. So we'll generate a constructor, and just the empty constructor right now. We're not going to take in anything here, or essentially we're not going to pass in any of the field values here. What we do want to pass in or take in as parameters here are the companies and the statuses that we want to list in these. So we'll add two parameters that we expect the user of this component to pass in. So we'll have a list of company objects, which will be the companies, and then we'll have a list of statuses, which will be the statuses. All right, and then we can start kind of configuring this form component. So first of all, I'm going to do the same thing as for everything so far. I'll add a class name, contact form. Then I will take the company combo box, and I'm going to call set items. And I'm going to pass in those companies that we got from the constructor. So these ones. Because these are our objects, I want to tell the combo box what property from there I want to show as the visible property. So I'm going to call company.set item label generator, and use the company name getter for that. We're going to do the exact same for statuses. So set items, pass in the statuses. Then we're going to set the item generator to status get name, like that. All right, and then we're going to add all these components to the layout. So we're going to call add, and we're going to just start with the first name, pass the last name, email. Then we'll have the company drop down, finally the status drop down, and then we're going to create a buttons layout for the save, delete, and close buttons. So we're going to split this out into a method of its own just to keep the add method here nice and clean. So we'll create a new method called create buttons layout, and we will obviously need to implement this. So we're going to create the method. It will return a component. All right, so for the buttons layout, we'll first of all need some buttons. So we'll go up here and create some buttons. So we'll have a save button, which will be a new button with the caption save. Then we'll copy this and create two others. So we'll have one for delete and one for cancel, like this. All right. And once we have those, we can go and configure them. So for the save button, what I want to do is call add theme variant, and we're going to use the button variant primary for this, which will make it stand out, be clear that's the primary action that we expect people to do. The delete button will add the theme variant error. So we'll again use the button variant and select the error one. And then finally for the cancel button, we're going to add the theme variant tertiary, like that. Okay. Then I'm going to add some click shortcuts so people using the keyboard can use these more efficiently. So for the save button, we want to add the click shortcut enter. And for the cancel button, we want to add the shortcut escape, like that. Then what we return from this will be a horizontal layout. So we want them to be horizontally next to each other. New horizontal layout, and we'll pass in the save, the delete, and the cancel buttons, like that. All right, so now we have a form that contains input fields for all the properties of a contact, and we have buttons for saving, deleting, and canceling. Now, just having this form will, of course, not kind of make it show up in our application. We need to go back to our list view here and add it to the layout. So let's do that next. All right, so back in our list view, let's create a field for the contact form. So we'll create a new field here called form. And then I'm going to add another configuration method here. So I'll call this configure form. Implement this. And in here, I first of all need to initialize the form. So the form will be equal to a new contact form. And as you remember, it takes in two lists. Now, at this point, we haven't connected to the backend yet, so we don't have any actual lists of companies and statuses. So what I'll do just for a placeholder right now is use collections.emptylist to just passing to empty list, collections.emptylist like this. And we'll replace those with the actual lists in just a moment. And then I'm going to give this form a width of 25 EMs, so that it has a width. All right, and what I want to change then, instead of passing in the grid here directly, we're going to create another kind of helper method for configuring this. So we're going to, instead of passing in the grid here, we're going to create a new method called getContent. And in this method, what I want to do is create a wrapper layout, a horizontal layout that holds both the grid and the form next to each other. So what I'll do here is I'll first of all create a new horizontal layout and pass in both the grid and the form. And I'm going to call this content. Then I'm going to define how these two will kind of be spaced. So by calling content.setFlexGrow, we can tell how the space should be allocated between these. So I want to say that the grid should get 2/3 of the space, and then the form should get 1/3 of the space, like this. So 2 and 1 for the flex grow here. Also for this layout, I want to add a class name. So I'm going to add class name and say content will be a good class name there. And finally, let's call set size full on this so that the content's the right size. And then instead of null, we're going to pass in the content here. All right. So again, if we look at what we did, we have a field here for the form. We configure the form by instantiating a new form passing in 2 empty collections for now. Then we pass into the view 2 components, the toolbar, which we had from before, and then a content, which is a horizontal layout containing the grid and the form next to each other. So if we go into the browser, we can see right now that we have the grid, we have the form here on the side, and we have the toolbar on the top. So we right now have all the UI components that we need for this view. The next step for us will be to connect this to our database and display and work with some actual data. So up until now, we've taken a look at the contact entity that we have, but let's take a look at some of the other stuff that we have from our starter. So in addition to the actual JPA entity classes that we have here, we have repository interfaces for each of those. So with the help of these, Spring Boot and Spring Data will give us the basic create, read, update, and delete operations that we need. All right, so in addition to those, we have a data generator that generates us some test data that we can work with. So that way, when we start accessing the database, we already have some context there to work with. Now, in order to hook up to the database, there are 2 different ways we could go about doing it. We could either just use the repositories directly to access the database, but in this case, it's a better practice for us to create a service class that works as a middleman here, running some business logic and kind of ensuring that we're not accessing the database directly from the UI layer. So I'm going to create a new class here called CRM Service. And this will be a Spring Service class, so we'll annotate it with a service annotation. And what we'll have here is, first of all, we'll need to have a constructor where we auto-wire in all those repositories that we need. So we'll have the contact repository. Then we'll have the company repository. And finally, we'll have the status repository, like this. Then I'm going to use the IDE to bind these to fields, all of them, like that. So that way we'll have access to all of these. So this service class will essentially have all the APIs that we'll use to connect to the database in our application. So the first thing I want to implement here as our public API is a method to find context based on a filter text. So let's create a new method here that returns a list of contacts. And I'll call this find all contacts that match a string filter text like this. And here, let's check first of all if filter text is null or if the filter text is empty. Then we will return the contact repository find all. So just return all of the contacts in our database. Else, we're gonna do a search. So we're gonna return the value we get from calling, again, the contact repository dot search and pass in the filter text. Now this is not something that exists yet, so we need to go ahead and add this. And here what I'll do is I'll use a JPQL query. Now I'm slightly lazy. I'm not going to type up the whole query, so I'll go here to the text version and copy this over and then explain what's happening. So what we do here essentially is that we name this search term here as a parameter, and then we use it in a query where we select contacts where the first name or the last name matches that search term, and we turn everything into lowercase so it's case insensitive. All right, so that takes care of the first piece of the API. So we have one way of finding contacts. So if we don't have a filter, we return everything, and if we have a filter text, we use that query to filter them. Next thing will be pretty easy. We'll have a public method again, returning a long called count contacts, and this will return contacts repository.count. All right. Next one will be for deleting contacts. So it can be a void method, delete contact, and this takes in the contact that we want to delete. And what this will do then is, again, delegate to the contact repository to delete this contact, like so. Then we'll do the same for saving contacts. So we'll create, again, a method for save contact, taking in a contact. And what we'll do here is, first of all, let's just make sure that we actually got a contact in, because sometimes if you mess up with the binder, it's easy to pass in a null value here, and we'll make our life easier if we check for that. So let's print out to the system error log that contact is null. So assuming as we actually have a contact, we can delegate again to the contact repository to save this contact, like so. Good. All right, so that takes care of all the contact-related ones that we need. Then let's create one for finding companies. So again, a public method that returns a list of company objects called find all companies. And this will return the company repository.findAll. And finally, we'll create a similar function for statuses. So we'll create a method that returns a list of status objects, find all statuses, and delegate this again to the status repository findAll method, like that. All right, so now we have a service class here that takes in all these repositories in the constructor through AutoWire. We have a way of finding contacts with a filter text, counting contacts, deleting and saving contacts, and then finding all the companies and statuses. All right, so now that we have this service here, we can go back to our list view and start using it. First thing we need to do is AutoWire it so we have access to it in our view. So we'll pass in the CRM service here. We can call this service, and we'll create a field for this so we have access to it throughout the entire view. Then, as the last thing here, I will call a new method, update list, which we'll use to update the list of contacts. So we'll create this method. And what update list will do is it will call grid.set items. And the items we'll get from calling service.findAllContacts. And then we need to pass in the filter value, which we can get from the filter text field get value. All right, so whenever we call update list, we'll go to the database and fetch all the contacts that match this filter that we have currently. All right, then we also need to hook up the filter text field to actually filter as we're typing. So we go here into our toolbar, we'll call filter text, we'll add a value change listener. And whenever that happens, we call update list. And as you remember, we're using this lazy value change mode, so it waits for the user to stop typing for a little while before it does that. And then finally, let's go here to the contact form and replace the companies and statuses with their actual content. So we'll use the service to find all companies, and then we'll use the service to find all statuses, like this. All right, so let's hit build. Let's build the application and see if everything worked out. So we'll go into our app here, and what we can see now is that we have all the contacts here. We should be able to filter them. So let's start typing in the first name here. And sure enough, that filters them down. We can clear the filter, and that shows all of them. What we should also see is the companies and the statuses that we passed in here. The next thing we want to do is hook up the form so that when we select people in the grid, the right person gets selected in the form and that we can edit them. We're going to do this in two parts. So first, what we'll do is we'll hook up the data binding in the form so that we can both edit and validate the input and trigger events from this form. And then once we have that done, we'll hook up this form to the grid so that whenever we select a contact in the grid, they'll get selected here on the side. All right, so let's begin by setting up the form here. For that, we're going to go back into the contact form class and create a binder. So let's create a new binder here. A binder is something Vaadin uses for binding between a model object and UI components. So in this case, we're going to work with contacts, and we'll call this binder. And we'll initialize this to a new bean validation binder. And this will, similarly to the grid, take in the contact class as a parameter. Now, what a bean validation binder will do is it will use bean validation annotations on the class that we have to provide validation also in the UI. So all of these not empty, not null, and like email validations will also get used in the UI. So that way we don't have to write the same validations twice, once in the UI and once in the backend. All right, so with the binder created, we need to call it as well. So here in the constructor, I will add a call to binder.bind instance fields and pass in this. And this is where the naming comes in. So as you remember, we named the fields here exactly the same as the field names in the contact. So that way the binder will take care of binding the first name property of the contact to the first name text field, and so on. All right, so now that we have the binder taken care of, let's add an API that we can use from the view to set the currently selected contact. So let's go and create a new method here, and we'll call this public method set contact, and this will take in a contact. And what we'll do here is we'll save the contact to a field called contact, and then we'll call the binder to read this contact bean. So that means the binder will read this bean that we pass in and populate these UI fields based on it. All right, so now that we have a way of passing in a contact and a way of binding the values from that contact to the UI fields, the next thing I want to do is define a couple of events that this form can fire, and that way kind of inform the view when something has happened. So especially we want a save event, a delete event, and a close event. For this, we're going to use Vaadin component events. And if we go again into the text version here, into the forms and validation chapter, you can see that we have a bunch of events here that I'll copy over and then walk you through. So we'll fix the imports here. We need to take the Vaadin Flow registration here. I'll close the sidebar so we can see this whole thing. So what we essentially do is, first of all, we create a base class for events that we emit from this form. And we extend from the basic component event that Vaadin provides. We add a field for storing the contact that we're working with. So whether we're saving or deleting that contact, we can save it here. Then we create specific events for saving, deleting, and closing, passing in that contact to those events so that we can get hold of the contact when we're listening to those events in the list view. Finally, we have a add listener method here that takes in the event type and the listener and adds them to the Vaadin event bus. All right, so now we have most of the pieces that we need to make this form a fully functional component. We have a way of passing in the contact, a way of binding it to the UI fields. The remaining piece of the puzzle is to hook up the save functionality and the delete and close buttons to actually fire the appropriate events. So for that, we're going to go into the button layout method here, and we'll start just binding these. So we'll add a click listener on the save button, and on the click event, what we want to do is we want to call a new method called validate and save. So there's a little bit more going on in the validation, so I don't want to do it inside the Lambda. I'll just split it out into a separate method here. So what I do here in validate and save is that, first of all, I'll try to call binder.writeBean, and we'll write the value from the binder back to that contact that we saved in a field. Then we need to add a catch for the validation exception here. For now, I'm just going to print the stack trace. In a more kind of real life application, we'd probably want to show some sort of visual notification to the user. But assuming that we get past this, we now have a valid saved contact. And what we want to do is kind of call fire event, and we want to create a new save event. And this will take in two things. So the source component, which will be this, and it will take in the contact, which is the contact. All right, so now we have the save button hooked up to both validating and saving the value from binder to the contact and firing an event. Next, let's do the same for the delete button. So we'll again add a click listener, and here the event should just call fire event, create a new delete event, we pass in this and the contact. Then we do the close button, or sorry, the cancel button. We add a click listener, and here we call fire event, new close event, and we pass in this. In this case, it doesn't make any difference what the contact is if we just want to close out of this. All right, so now we have a complete API for our form. We have a way of setting a contact. Whenever we set the contact, the binder reads that bean. Because it's bound here to the instance fields, that means that it will populate all the UI fields with that. And then we hooked up the buttons so that whenever we save or delete or cancel, we fire an event. So at this point, we just want to build and make sure everything works. There's no visual kind of changes to our application so far. So what we need to do next is go to the list view and hook it up so that whenever we change the selected contact here or click add contact, the right contact gets populated here. And whenever we save or delete, we actually want to do those save and delete operations to the backend. Okay, so let's jump into the list view again and see how we can manage the view state. So by the view state, I mean that when we select a contact, we want to show that editor with the right contact. When we close the form, we want it to actually get hidden. And when we either save or delete a contact, we want those to be hooked up to the backend. Okay, so first thing I want to do is start the view off in the right state. So with that, I mean that when we start the application, we don't have a selected contact, so we shouldn't be showing the form. So we're going to call a new method called close editor. And what close editor does is it calls the forms set contact with null. Then we'll call form.setVisible false, so we hide the form. And then finally what we'll do is we'll remove a class name of editing. This is something we'll add when we start editing. And the reason for that is we'll add some responsive styling so that when we're editing on a narrow screen, we can hide the grid and the toolbar to give all the space available just to the form. All right, so now that we start the application, we navigate to this view. We start off in the right state. So we've closed the editor and we don't see the form because we don't have anyone selected. So the next thing we want to do then is handle somebody getting selected. So for that, let's go into the configure grid method here, and then we'll add a listener. So we'll take the grid as a single select. So grid supports both multi and single select modes. Because we only want to select one component, one contact, we can use the as single select and add a value change listener here. All right, so when this happened, what we want to do is we want to call, again, a new method, edit contact, and then we get the value from the event like this. And again, we'll create the method here, and we'll call this contact. All right, so what we need to do here is handle two different cases. One is the contact may be null. So if somebody deselects a selected contact, we need to close the editor. So that we already have. Good. And in other cases, we need to do something about this. So essentially, we need to do more or less the opposite of what we did just a while ago. So we call form.setContact. We pass in the contact. And then we set the visibility to true because we want it to be shown. And then we add a class name of editing here so that we can use that for our responsive styling in just a moment. All right, so now we have hopefully a way of selecting a person in the grid. Let's build this and see that that works. So now we can see that when we start the app, we don't see the form. And when we select somebody in the grid, we can see the right person getting shown here. And if we click the same person again to unselect, it hides them. All right, so next up, let's hook up the add contact button here. So for that, we'll go into the get toolbar method here, and we have the add contact button already created. So we'll take that, add a click listener, and for that, we want to call add contact. And we want to create the method here. What we want to do is we want to take the grid as a single select again and clear it, meaning that when we create a new contact, we don't want a different contact to be selected in the grid because that would be slightly confusing to the user. And then once we've cleared the grid, we can call edit contact and create a new contact object. So start off with a clean slate. All right, so we'll save this again. Just make sure that we're on the right track. Everything is working. The reload is kicking off here. So we can still select people here, and we can create a new contact by clicking the add contact here. Now, I hinted towards making some responsive styles. So right now, if we're on a very narrow screen, you can see that this isn't really an optimal use of space here. It would be better if we could just have the entire space available here for the form. So for that, we can add some CSS. And again, we're going to cheat a little bit and go to the text version and copy those styles. So we're going to go here. We're going to copy these, and we're going to put them in the theme folder. So we're going to go into the frontend directory, to the themes, and select the style CSS here. Right now, you can see it's only pulling in some icons, and we'll add our own style here beneath that. All right, so what the style does is that it adds for narrow viewports on the list view. Whenever the editing class name is present, it will hide both the toolbar and the contact grid. So we'll go ahead and save this, and then we'll go back to the application and see if that got picked up and works. So we'll refresh this, and we'll see if this works. So now you can see that when we go on a narrow screen, we can actually get the entire screen as real estate available for the form, which is much nicer. Now, of course, we need to have a way of getting out of this, and that's the next thing we're going to do. So we're going to hook up all these buttons to actually do something. So again, we'll go into the list view, and here we're going to go into the configure form method, and we're going to add listeners on the form for those custom events that we created. First event I'm going to hook up is the save event. So we'll take the form, we'll add a listener for the save event class, and then we're going to hook it up to a new method on this called save contact. Then we'll create a new method for this. It's going to be a private method, void save contact. This takes in the save event. We'll call this event. And what we want to do here is then use the service to save the contact by getting it from the event, like that. Once that's done, we can call update list to make sure that all the updated data gets shown, and then we'll call close editor, like that. All right, so that takes care of saving. Next, we'll take the form, add a listener for the delete event. And again, we're going to take the class, and then we'll create this dot delete contact. And similarly, we'll create a new private method for that, taking in the delete event. And what we want to do again is defer to the service to delete the contact. So again, we can get that from the event. And then we want to call update list to make sure the list is up to date. And then we want to close the editor, like that. Then finally, we want to add a listener for the close event. And this one will be easier because we only need to call close editor, like that. So now we have those events hooked up here, so that whenever we save or delete, we defer to the service and close the editor whenever we do anything. So let's try this out. Let's change a contact here, click save. We can see that that gets shown here. We can delete that person and they disappear from there. And finally, we can try out the close here. So if we click on cancel when we're editing, especially on a narrow screen, we can see that that hides the form as expected. So up until now, we've only been working on the list view. The next thing that we're going to look at is adding an app layout that has this responsive drawer with navigation links and a header. And that will allow us to then add a second view for a dashboard that shows stats over the context that we have. So in order to add this main layout, we're going to go into our Java code again, to the views package, and I'm going to create a new Java class here called main layout. And main layout will extend from app layout, which is a Vaadin class that implements that drawer layout. In here, I'm going to implement a constructor and essentially split out two helper methods, one for creating the header and one for creating a drawer. So I'll call create header and create drawer, like that. And go ahead and create these methods like that, and we'll start implementing them. So for the header, we're creating a new H1, so just a header level 1 that says Vaadin CRM, and we can extract this into a variable called logo. And for logo, I will add a couple of class names. The ones I will add is text L and margin medium. The class names here are part of the new utility classes in the Vaadin Lumo design system. So you can find all of these described here under the design system documentation if you want to use some of the other ones in your application later on. All right, so we have the logo. We've adjusted the text size and the margin. And then what we'll do is create a new horizontal layout to hold on to everything that's going to go into that header. So we'll create a new horizontal layout, and we'll pass in a new drawer toggle, which is something the app layout uses for toggling the drawer, and then the logo. And this will be the actual header itself. Then for the header, we want to set the default vertical component alignment to center to make sure everything's nicely aligned. We want to call expand on the logo, meaning that the logo should take up all the extra space in this layout. We'll need that a little bit later on when we add the logout button. Then we'll set the header width to full, like that. And then I'm going to add some utility class names to this one as well. So I'm going to call add class names. Put the padding in the y-axis to 0, and the padding in the x-axis to medium. With the header configured, I'm going to call add to navbar and pass in the header. So this is perhaps a little unintuitive that the slot that we're using for the header is actually called the navbar according to the app layout, whereas the drawer is what we will use as our navbar. So the drawer then is where we have the links to the different views. Here we'll create a new router link, which is something that we can use to navigate to a view. So we'll give it a caption list, and this will navigate to list view.class. All right, so that'll be the list view. And for the list view, we'll set the highlight condition to highlight conditions, highlight conditions dot same location. The reason I'm setting this is that for the default path, the empty path, essentially that would match any path because every path starts with an empty path. So this is something we need to have here just so it doesn't stay highlighted because it thinks every other view essentially in our application would be a sub view of this. All right, so once we have that, we're going to add to drawer, and we're going to create a new vertical layout. So we want the links to be vertically aligned on top of each other, and we'll pass in the list view link here. Now that we have the highlight conditions here on the links, the other thing we need to do is define how we want to style those. So go into the text version again, copy some CSS here, and we're going to go into the front-end folder once again, into the theme folder, to the style CSS, and add this style. So anytime a link has the highlight attribute, we're going to bold and underline it. All right, so with the main view now created, we need to go into the list view and tell it to use this main layout. So here where we have the route, we need to add a layout parameter and set this to be main layout.class. This way, whenever this view gets loaded, it will get loaded inside of main layout. So let's build this and go into the application and see that what we have looks somewhat to be on the right track. So you can see we now have the header here. We have the drawer toggle that we can use to toggle this drawer, and we have the link here, and it's highlighted, so it's bold and underlined. So that looks good. Now that we have the main layout in place, and we have a place to actually have links to different views, we're ready to add another view to our application. So for that, I'm going to go into the views package, here my Java source, and create a new Java class. I'm going to call this dashboard view. And dashboard view will extend from vertical layout, the same as list view. We're going to give this a route annotation where the value is equal to dashboard, and the layout is equal to the same main layout.class. We're also going to give this a page title. This will be dashboard. We'll have the same Vaadin CRM. All right, so the dashboard view, if we kind of look at what we're aiming to do, will look something like this. So we'll have the amount of context we have in our system, and then a pie chart showing how those different contexts are split into different companies. So here in our class, let's create a new constructor first of all. And here we will auto wire in the CRM service. We'll call it the service and save it into a field called service like this. And then I'm going to give this a class name the same way as we've done for everything so far. So add class name, dashboard view. Then I'm going to set the default component alignment to center. So we want everything to be centered horizontally in this vertical layout. And then we're going to call add and create two helpers again. So one for get contact stats and one for get companies chart, like that. Right, so we'll go ahead and create these methods like that. And let me just rearrange these so they're in the same order. So we'll start with the easier one. So get context set. So here we need to just show essentially a text with how many contacts we have in the system. So for that, we can use a span, just a plain HTML span. And here, the number of contacts we can get from the service by getting count contacts and calling plus contacts to concatenate a string. So this will be our stats, essentially. For the stats, we'll add some class names again to configure how it looks. So we can use text extra large, and then I'll set the margin top to be medium, so it doesn't quite touch the top there. And then we'll return the stats here. All right, then for the companies chart, we need to do a little bit more. So for the chart itself, we're going to use Vaadin charts, which is part of the Pro library. So if you're doing this tutorial and you want to try it out, there's a free 14-day trial. Or if you're a student, it's part of the free student package, so you can get it from there as well. So we're going to create a new chart. And this will be of chart type pie. And this chart will then need to get its data somewhere. So for that, we need a new data series. And we're just going to pull this out into a variable. And then what we need to do is call service, find all the companies, and then for each of them, kind of pull out the stats. So for each company, what we can do here is call data series.add, create a new data series item, and this takes in two things. Essentially, it'll be the company name and then the count of employees in that company. So we'll take company.getName and then company.getEmployee count. And that's something that doesn't exist yet that we need to create. For that, let's go to the text version here and copy a little bit, and then I'll explain what's happening. So we'll go into the company class that we have. So in data entity company, we'll go here and we'll add this employee count. Now there are essentially like two ways we could have gone about getting the count of employees. We could have actually fetched all the employees from the database and counted them, but that's not very efficient because we only needed to know how many there are. So instead we can use a formula to just count how many there are and have a getter that calls that. So now we have added a series item where we get the name and the amount of employees in each company here. And the final thing that we need to do then is we need to take the chart, we need to get the configuration, and we need to set the series to this data series that we have like this. And then finally, of course, we need to return this chart. So again, if we look at the big picture here, what happens is that we have a vertical layout that centers everything on the horizontal axis. We add two components, a span containing stats, so just the total number of contacts in our system, and then the other one being a chart, which is a pie chart that pulls from the service all the companies and then uses the formula to get the employee count in each. So let's save and build this. And right now, if we go to our application, we should be able to go to dashboard and see it here. So the dashboard view itself now works. Obviously, we want to add it here to the main layout. So let's finalize this dashboard view implementation by going into the main layout and then adding it here. So for that, we're just going to inline it here. We're going to do a new router link to dashboard, and that will navigate to dashboardview.class. Save and build. Go to the application. See that we now have the dashboard view here. It's highlighted because we're on the dashboard view. We can go to the list view. Let's go here, delete one contact. Go here, verify that the number of contacts here has actually been updated, which it has. So that looks good. We now have two views in our application and we can navigate between them. Up until now, everyone could access everything in our application, and that's not what we want to do. So next, let's secure the application with Spring Security and add a login screen. So we're going to begin by creating the login screen. So here in the views package, we're going to create a new Java class, and we're going to call this login view. And login view will extend from vertical layout the same way as other views that we'd had so far. So vertical layout, and we're going to implement the before enter listener. So that way we can hook on to the before enter event. And we'll get back to that in just a second. Okay, so first of all, let's add a couple of annotations here. So first one being the route annotation. We're going to map this to the login route. And then we're going to give it a page title that will be login, and then a pipe and Vaadin CRM. All right, then what we're going to do is we're going to override the constructor. And in the constructor, we're going to start constructing the view. For the actual login, we're going to use a login view component. So I'm going to instantiate it up here. I have a private login form. We can call this the login, and that will be equal to a new login form. Then in the constructor, we're going to add a class name, login view. We will set the size to full, and then we'll align components both in the horizontal and vertical direction. So we'll set the line items to center, and then we'll also set justify content mode to center so that everything's centered. Then we're going to configure the login action, so where this login form should post to, and that will be the login path. And then finally, we'll add the components to the layout with add. We'll create a new H1 with saying Vaadin CRM, so people know what they're logging into, and then the login form. All right, and in the before enter listener here, what we want to do is check if the URL has a error query parameter, and if so, we're going to show that error. So if the before enter event .get location .get query parameters .get parameters contains a key called error, we know that we have an error that we should show. So we'll take the login form and set the error to true, like that. Okay, so save and build. And what should happen right now is that we should have the login view available, but it's not enabled yet. So there's nothing that forces us to go there, but we can navigate there manually. Because we didn't use the parent layout, you can see that we don't have the wrapping app layout here. We just have the login form, and that's exactly what we want. Okay, so the next step will be to actually enable Spring Security. For that, we need to first install a dependency. So we will go into the POM file, and we need to install the Spring Boot Starter Security dependency. So just going to copy this over and change validation to security, like that. Then it's important to actually fetch the Maven dependencies. So go ahead and do that before continuing. And once that is done, we need to turn off the server and restart it, because otherwise those won't get picked up. So while that's happening, we can start configuring Spring Security. For that, we're going to go into our application package here, and we're going to create a new package. We're going to create a new package called security. And here we're going to create a class called security config, where we can configure how Spring Security should work. Because right now you can see it's not using our login view, it's using Spring Security's default login view, which doesn't look as nice. All right, so how do we use this security config? First of all, we need to tell Spring to enable web security, and then we're going to tell that this is the configuration that we want to use. Then we're going to extend from Vaadin web security configure adapter. Quite a mouthful, but that's the kind of naming convention that's used here. Let's hide the sidebar so we have a little bit more space to work with here. And we need to override a couple of methods here. So we're going to override configure for HTTP security. And we need to make sure that we call super.configure to let the Vaadin web security configure adapter do its thing. And then we are going to set the login view to login view.class. So that way we're going to use our own login view. And we actually need to pass in the HTTP configuration object there as well. All right, so that configures one thing. The other thing we want to do is we want to exclude an image directory from Spring Security altogether. We can do that by overriding configure. And here, again, we need to make sure that we call the super configure, but let's first ignore a path. So we will take the web configuration object, call ignoring, pass in antmatchers for /images ***. So anything under the image directory should be ignored by Spring Security and just served as it is. And then finally, let's configure a user for our system. We can do that by defining the user details service. So user details service. And here we're actually configuring a bean. So let's add a bean annotation here as well. And we're not going to use super here, but we are instead going to use an in-memory details manager. Now, this is not something that you would ever want to use in a production application, but for this demo, it's very good. In the Vaadin documentation, you can find examples of how to hook up to an LDAP or another authentication provider for any actual application usage. So for this, though, we're going to just create an in-memory user details manager. We're going to create a new user with the builder. So we're going to say with username, user. Then we're going to give it the password. Since this is just an in-memory demo, we're not even going to bother with encrypting the password. So we're going to say no op, user pass as the password. Then we're going to give it some roles of user, in this case, only single role. And then finally, call build. So what we have right now is a security configuration using the Vaadin Web Security Configure adapter, setting the login view to our custom login view, ignoring the image folder from web security, and using a single user in memory with the username user and password user pass. All right, so let's save and build and go to the application and see what happens. Now that we're on this Spring Security-based login page, it's not going to have the live reload, so I'm going to navigate to the app myself. And what you can see happens immediately is I'm getting redirected to the login page here, which is what we would expect because we've now secured the application. So let's try to log in, user pass, login. And we got logged in, but we can't access any views. So the last thing we need to do here is actually grant permission to views that we want the user to be able to access. So open the sidebar here and let's go into the views here. So here I'm going to add a permit all annotation saying that all logged in users should be able to access this. And similarly for the list view, we're also going to add a permit all annotation like this. So now if this reloads, we should be able to access the list page, and we are. So still reloading. There we go. Now we're able to go between these two. Now we have a way of logging in. The last thing kind of regarding security that I want to do is add a logout button up here. So for that, let's go back into the security package and create a new Java class, security service. And in security service, well, first of all, let's remember to give this a component annotation so we can auto-wire it. And what I want to do here is do a public method for logging out. So we call it logout. And here, two things that we need to do. First will be to get the current UI, get the page, and set the location to the path. So we want to navigate the user to the empty path after logout. Then we're going to create a new security context logout handler. Context logout handler. Like this, pull it out into a variable. We call it logout handler. And finally, we're going to call logout handler.logout. It takes in three things: the request, response, and authentication. But in this case, we only need to pass in the request. We can get that from the Vaadin servlet request.getCurrent.http servlet request. And let me hide that. And then pass null values for the others because they don't matter for this. Okay, so now that we have a service method that we can call to log out, let's go into the main layout and add that to our header. So here, I'm going to create a new button. So new button, log out, and it will have a click listener. So whenever it gets clicked, we want to call the security service to log out. So for that to work, we actually need the security service. So let's auto-wire it in here. Security service, let's call this security service, create a field for it, and then call security service.logout in the button. All right, then we're going to add this to our header here. Well, first of all, we actually need to pull this into a variable. We'll call it logout, and we're going to add it here. All right, so save and build. And if everything goes well, we should have a logout button, which we have. And when we click on it, we get logged out and sent back to the login page. And we're able to log back in. So we've now successfully secured the application and only permit access to those who are logged in. Our application is now basically complete, but there are still a couple of things I want to do. The first one is configure how the application looks when we install it and when it goes offline. And when we're done with that, we're going to take a look at testing the application with unit tests, integration tests, and end-to-end tests. Okay, but let's first take a look at configuring the application installation experience. So every Vaadin application is a progressive web application by default, meaning that people that supported browsers, essentially most browsers these days, will be able to get an enhanced experience where some things will be cached automatically in the browser for faster access, and on many browsers they're able to actually install the application either on their desktop if they're on a computer or on their mobile device. You can configure some PWA attributes here in the PWA annotation on the application class. So I'm going to change the application name here to Vaadin CRM and give it a short name of CRM. So this is the short name, essentially what goes under the icon on, say, a mobile device, if the full name can't fit there. Okay. The next thing I want to do is configure the logo, kind of update that to match our application. So for that, again, we're going to go to the text version here, to the PWA chapter, and download both this image and this image so that we have them. So once we have the images, let's go and put them in the right places in our application. So the first one we need to put under meta-inf resources icons. So that would be, if we make this a little bit bigger, so we go resources, meta-inf resources icons. So we're going to drag the icon here and replace the one that's already there. So we'll overwrite that. And then the other thing is the offline icon, or image, sorry, and we're going to put this in the images directory here. So we'll move that there, and that takes care of that. Okay, so what I want to do next is configure how the application behaves when it goes offline. So by default, you've noticed sometimes when I refresh, you see this dark page saying that the application is offline and you need to go online to use it. But we can customize that page to kind of match our application. And in a real life situation, that gives a better user experience to the user. So we're going to have our own custom HTML file for that. And it needs to be called offline.html in the same resources folder. So we'll create a new file here, offline.html. And we're going to paste in the content that we copy from here. So what we have is a plain HTML document with some styles, pulling in this image that we just put in there, and has a custom text here. And finally, it has a script that listens for when the browser goes back on or detects being back online, and that's going to reload the browser. So hopefully that will get us back into the application. All right. So let's configure these in the PW annotation on the application. So we have let's put these on separate lines so it's easier to see them. So we have the offline resources here. We have the logo already made offline. And what we're going to add here as the other one will be images offline.png, like that. So that way we have that. We can also define the offline path to be offline.html so that the custom HTML page that we have gets picked up. All right, so let's save and build this and go to the application. And we're going to wait for this to reload. And what I want to do is just verify that these things got picked up. So I'm going to open up the developer tools, and I'm going to go into the application tab here. And first thing I want to check is that the manifest got updated. So I can see the custom icon here, but for some reason this isn't updated yet. So it seems like something is still kind of getting cached somewhere. So one thing you might want to do is just go ahead and clear the site data once and refresh this to make sure that all the new stuff gets picked up. Now we can see we have the correct icons here. And we should also be able to see that there are some things cached here. For instance, our offline page. And we should also see our offline image here. Okay, so now that we have those, let's log in here, user pass. What we can do as a user now is install this application. So depending on the browser, the installation experience will look a little bit different, but on Chrome, it's up here in the nav bar. It'll ask if we want to install the app. We can go ahead and say, yes, we want to do that. And what happens now is that you can see that my application is here with its own icon. It's in its own window. And now I can use it as a standalone application. So that's pretty cool. Let's go ahead and check out the offline page. So I will go and turn off the server. And then let's go ahead and refresh here and see. So now we can see that we're offline and we have a custom offline page for that. So we've now turned the application into an installable PWA, and we've customized the icon and the offline page. All right, so with the application completed, let's take a look at writing some tests. I'm going to close the standalone application here and just open it up in the browser once again. So I'll just go to localhost 8080. We're still offline, so we can also go ahead and start the application. All right, so what we need, first of all, is a place for the tests to live. So up until now, we've only been working here in the source main Java folder, which is where our application sources live. What we're going to add now is a separate test source root for tests. So here in the source folder, we're going to create a new directory called test. And you can see IntelliJ is actually already suggesting that we create a test Java folder for Maven. So this will essentially be a parallel and identical structure to the one we have with the actual application source. And here it's actually really important that we use the same exact package structure, because we're going to rely on package access to some variables for testing. So let's go ahead and create a package for the list view. So I'm going to go here to package and create a com example application views list package. So that will be exactly the same path to the test as it is to the list view here. And in here, we're going to create a unit test that tests the contact form. Now there's a little bit of setup here, so I'm going to go again into the text version here and copy the boilerplate, and then we can go through it together. As you're copying these, you can go ahead and just paste them straight on top of the package, and IntelliJ or your IDE usually will take care of creating the class. So what we have here is a test that has a before annotated method here for setup. So before every test that we run, we have a setup phase where we instantiate all these fields to known values. That way we have a way of kind of validating if the right thing happened. So what we have is a list of companies and statuses. We have a contact. We have 2 companies and 2 statuses that we want to check. So we instantiate the companies. We add 2 companies to it. We instantiate the statuses with 2 statuses. And then we create a contact where we set the status in the company. Okay, so now that we have known values for all of these, let's go ahead and create a first test here. I'm going to create a public void method called form fields populated, which will check that the correct form fields were populated. So for this, we're going to create a new contact form and pass in the companies and the statuses, just like we would when we instantiate it in the UI. We're going to pull this into a variable. We can call it form. And then what we will do is we'll set the contact here to this known contact that we have, Mark Usher. Okay, so then what we want to do is we want to assert that the right values are visible in the UI field. So for that, we can use assertions. And we're going to assert equals. And we're going to, first of all, expect that the first name will be Mark. And we're going to get the value from the form first name field by calling getValue, like this. Okay. Then, second, let's validate that the last name is correct. So we'll change these to last name. Then we'll do email. All right. And next we'll do the company. So we want to make sure that company 2 got selected. So we'll get the company value. And finally, we'll validate that the status 1, so the ones that we selected here, are selected. All right. And for this to become a runnable test, we need to add a test annotation on it. And you can see, at least in IntelliJ, you now get this little helper here where you can run it. So you can go ahead and actually try to run this. And hopefully, if things went well, we'll see that we get a little green check mark here saying that the form works the way we wanted it to work. Okay, so now we have a test that validates that the right things get populated in the UI. Let's create another test that tests that we get the right values when we modify something and save it. So for that, let's create a new method again. All right, and we're going to annotate this with a test annotation as well. So again, let's create a new contact form, pass in the companies and the statuses. Pull this into a variable called form. And then let's create a new contact. We'll call this contact. And we set this empty contact to our form. So we call form.setContact with this empty contact that we have. And then we'll start populating the UI fields programmatically. So we'll get the form, get the first name field from there, and then we'll set the value of that to a known value. So we can say something like John. All right, we'll do the same for the last name. Set the value to Doe. Then we'll do the email. Set value john@doe.com. Next, we'll do the company. We'll set the value to a known company. In our case, we can set the company 1. And finally, we'll set a status to a known status, so we can use status 2 just to mix things up a little bit. All right. And as you remember, when we save something, we actually get an event back. So what we'll do is we'll create an atomic reference where we can capture that value that we get back from the event. So we'll do a atomic reference to a contact, and we'll call this saved contact. And we'll just instantiate the new atomic reference like this. And in this case, we don't have an initial value. All right. Then what we want to do is we want to add a listener on the form so we can capture that saved contact. So we'll add a listener for the save event. And the event then, what it will do is it will take the saved contact and set the value to the contact that we get from the event, like this. So that way we're able to pull out the saved contact from there. And that's exactly what we'll do. So we'll have our contact. We can call it saved, and that will be equal to the saved contact.get. So that way we now have an object here which has all the information of that saved contact. And what we want to do then, again, using assert that things are equal. So we want to make sure that that John equals the saved contact's first name. Doe equals the last name. John@doe.com equals the email. Then we'll do the same for the company. In this case, we'll use company1 should equal to the company. And finally, the status, I think we used status 2, should equal to the status, like this. All right, so let's try this again. We'll run this test, and hopefully everything goes well. Okay, so something did not pass. Let's take a look at what's going on here. All right, so cannot invoke get first name because saved is null. All right, that makes sense because I actually forgot a pretty important step here. So we actually need to take the save button and actually click on it for that event to get triggered and for us to have a saved contact. So let's save that. Let's rerun the test. And sure enough, it passes. So now we've created 2 tests. One, making sure that when we pass in a contact, the right fields in the UI will get populated. The other one will start with an empty contact, programmatically fill in the fields, click on the save button, and make sure that we get back what we expect. Now that we have a couple of unit tests that test the form by itself, let's create an integration test that tests the list view and making sure that the interaction between these 2 components that it comprises of actually works. So create a new Java class here, and we're going to call this list view test. And list view test will be slightly different because we're going to use a runner here. So we're going to define run with and say that we're going to use Spring runner.class. So we're going to use Spring here so that we can use auto wiring and stuff that the view needs. And we're also going to add a SpringBootTest annotation here. All right, so with those in place, we can now auto wire things here. So we're going to auto wire in the list view like this. And then let's create a new test. So for that, a public void form shown when contact selected. So we want to make sure that the form is shown when the contact is selected, and this will have a test annotation on it. All right, so you can see that this isn't working right now because there are no beans of type list view found. So what we need to do to fix that is go here and add a component annotation and a prototype scope. So add a scope prototype like that, so that we always get a new version. The reason we didn't need to have these earlier is that when we're navigating through Vaadin, Vaadin will take care of actually making sure that everything gets auto-wired. But since we're not using Vaadin right now, we need to make sure that Spring can find these on its own. All right, so we'll go back into our list view test, and now you can see that the error is gone. Okay, so what I want to do here is I want to find the first person in the grid, select them, and verify that the contact form shows that right person. So for that, we need a little bit of code here. So first of all, let's use the list view to get the grid, and we can pull that into a variable. And then we want to find the first contact. So let's do a method, a little helper for that. So we can call get first item on grid, and that's going to return the first item. So we'll go ahead and create this method. This will return a contact and take in the grid. So the way we get the contact is by calling grid and getting the data provider. That's kind of what's holding on to all those items. And we're going to cast this into a list data provider of type contact, like this. And then we can call get items on this, get the iterator, and get the next contact from there. And then we can return this. So now we have a way of pulling in the first item from the grid. All right, and we will then pull this into a variable. And we're going to call this the first contact. All right, so now we know who is the first contact here. Then let's get the form. So list view.form, pull that into a variable called form. Then we'll do some assertions. So first we'll assert that the form is not visible. So we can use assert again, assert false. And we want to assert that form.isVisible is true. All right. So once we know the form is hidden by default, we can take the grid, a single select, and set the value to the first contact. So we essentially programmatically now select this first item. Then let's assert that the form is visible and that we actually get the right person shown in the form. So assert true, form.isVisible. So the form should be visible. Then we'll assert equals that the first contact that we know we have, that their first name is equal to the form first name field value, like this. Okay, so let's go ahead and run this and verify that everything works. So one thing you notice here is that this is taking quite a bit longer than it did for the unit test. That's because we now have to actually start up the Spring DI container. So there's a little bit of a trade-off when you start doing this integration test where you need to involve Spring, but for the most part, that's fine. And it allows you to test the application integrations in a more realistic setting. So we can see that this now works. We've validated that the form is initially not shown. When we select the first contact, the form gets shown and the first name is valid, so we can assume that the right person got shown there. And we have the other unit tests that actually verify that the form itself works. And then the final type of test that I want to write for this application is an end-to-end test. So something that tests the application all the way from the browser to the database. We can do that using the Vaadin TestBench tool, which again is part of the Vaadin Pro tools. So if you already started a trial with the charts, the same trial will work for this as well. So let's set this up by going into the test folder again and creating a new package under application called IT. IT standing for integration test. The end-to-end tests are essentially a very wide type of integration test that tests the entire application. There's a little bit of setup when we create a TestBench test. So let's go to the text version again and copy over this abstract test that we can use then to extend from. So we'll paste this over our new package. Let's close some of these so we can see what we have here. So the abstract test defines some constants here for the address and port, and it takes in a route through its constructor. Then it turns off some logging in the Apache HTTP client so we don't get too much spam in the console. And then it does some setup. So before the class starts, it starts a Chrome driver. And if something fails, it grabs a screenshot. And then the setup essentially gets the driver and opens up the URL that we want to test. So with that, we can now start building our first test. What I want to test is the login functionality. So I should be able to log in with a valid username, and I should be denied login with an invalid username. So let's create a new Java class for that. Call it login IT. The naming here is important because Maven uses the IT postfix to run these tests at the right build phase. So create the new login IT, and then we can start defining our test. So first thing we need to do is extend from abstract test that we just created, and it will require us to create a constructor. We don't want to pass in a route, but instead we're going to say that we're going to be testing the empty route. So that takes care of the setup thanks to the abstract test. Now the next thing we want to do is create an actual test. So we're going to create a public void login as valid user succeeds. So this should validate that a login with a correct username and password succeeds. Annotate this with a test so it becomes runnable. And the way this works is that we can use these element selectors to grab hold of references to UI components in the browser. So in this case, I'm interested in getting the login form element, and I want to get the first one that's visible on the page. In our case, it's the only one. Let's pull this into a variable form. Then let's set the values on the form. So we'll call form.get username field .set value user. Then let's get the password field, set the value to user pass. And then finally, we'll get the submit button and click on it. And then what we want to assert is that we're no longer on the login page. So what we can do here is can assert false that a new element selector for the login form element .class exists. So we want to make sure that it does not exist. Okay, so let's save this. And when we run these through the IDE, we want to make sure that the application is already up and running. That way we can run these tests quicker because it doesn't need to start the application every time. When you're running them through Maven in the integration test phase, it will start the server for you, but that takes some extra time that we don't want to do while we're developing actively. When we run these, it's important that we run the entire class to make sure that all those before class annotated setup things get run. So we'll run the entire login IT test here, and then let's see what happens. All right, so something failed here. All right, gonna take a wild guess that this was made a protected method. Let's try to make it a public constructor just so it can get run properly. Let's run that again. And yes, okay, so now it opens up Chrome, logs in, and sure enough, we get a green check mark here saying that everything went well. All right, so now we have one test that validates that you can log in successfully with the correct username. To make sure somebody can't log in with an invalid password, we could just copy paste this whole thing, but something that you usually want to do is create these elements for your own views so that you can easily test different variations without having to copy paste too much code. So I'm going to create a sub package here called elements. And inside of it, I'm going to create a login view element class. What we're going to do here is define some attributes. And we're going to say that the name here will be a class, and it will contain login view. So in our login view, as you remember, we added a CSS class login view, and this will help us find the right one. Then we're going to add an API here for a method for logging in. So public Boolean, so we return whether or not that worked, and login is the method name. We'll take in two strings, user name and string password. Then what we can do is essentially do what we did here earlier. So let's copy this over, move it here, and instead of using these hard-coded values, we'll pass in the username, pass in the password, okay, and the reason this is not working is that I actually forgot to extend from a vertical layout element. And when we make these elements, it's really important that we have the same class structure. So if we look at our login view, you can see that it extends vertical layout and it has this class name. So we also extend from vertical layout, and then we use the class name here to bind. All right, so now we pass in the username, we pass in the password, we click, and then finally we're going to change the assertion. So we're not going to do an assertion here. Instead, we'll return the negation of a check of this login view element being visible. So we'll do a login view element.class on page that exists. All right, so now we do the same and we validate that we no longer have the login view on the page. We can go back to the test that we had here and we can simplify this. So what we can do is we can do element selector for the login view element and get the first one of those, pull that into a variable, so login view, and then we can assert that the login succeeds. So we can assert the login view.login with user and user pass works. Okay, so let's validate that first of all continues to work. So everything should work the exact same way as it did just a moment ago. Chrome starts up, it logs in, and the test passes. So now we have an easier way to test that the opposite does not hold true. So login as invalid user fails. So we'll do the same, but we type something else here, and we assert that this would be false, of course. So now if we run this, we should see 2 green check marks validating that this works. All right. And sure enough, we have 2 green check marks. So this is just a very quick introduction to Vaadin TestBench. So you create an abstract test that you can use as the base for just setting up all your tests. And then you can create these elements for your views to kind of encapsulate some of the common things that you want to do to avoid having to repeat yourself too much. And then finally, you can just do normal JUnit assertions on things that you expect to happen when you run the code. Now that we've created our application and tested it, the last thing that remains to be done is to publish it somewhere where we can share the link to others. Before publishing the application, we need to create a production build of the application. We also don't want to use the in-memory H2 database when we're running in production. Instead, we want to use a Postgres database. So let's do a couple of changes to the code so that we can get ready for deployment. First thing I want to do is go into the Maven POM file here and go into the production profile. So this is something that Vaadin Maven plugin comes with that we can use to build a production ready application. So it minifies some of the front-end assets, it turns off unnecessary debugging, and in general makes the application suitable for production. So what I'm going to do here is I'm going to add some dependencies specifically for Postgres, so that when we're running in production, we want to use Postgres. So we're going to use PostgreSQL from org PostgreSQL, like that. Then we need to go into our Spring application properties and define some things here. So I'm going to say Spring JPA .generate DDL is to true. And I'm also going to say, in this case, Spring JPA hibernate DDL auto to create drop. So this will create and then destroy the schema at the end of the session. Now I want to warn you that don't do this with an actual application. In a real life situation, you don't want to create and drop the database every time you deploy. But for our demo purposes, that's perfect. In a real life application, you really want to use something like Liquibase or Flyway to handle your database migrations so that you don't lose data. So keep that in mind. All right, so we now have everything that we need. The next thing that we want to do is create a production optimized jar. So I'm going to open up a terminal, navigate to the desktop, to the Flow CRM tutorial, and then I'm going to run the Maven wrapper that comes with the project. And I'm going to run the clean and package targets and use the production profile that we just configured. And this will do a production build, and the result of that will be a jar file that we can go and deploy. Now, while that's doing its thing, let's look at the deployment here in the text version. So we're going to deploy to Heroku. You can deploy Vaadin apps on any cloud provider or pretty much anything that runs a servlet, but Heroku is a really easy place to get started, and it's free without requiring a credit card. So it's a nice place for us to deploy to. What you need to do is create a Heroku account, and you need to follow the instructions for installing the CLI. All right. So we now have the package built here, and we can go ahead and start deploying it to Heroku. So the first step that you want to do is log in to Heroku with Heroku login. I've already done that, so I don't need to do that once again. The next step will be to run Heroku plugins install Java. So plugins install Java. So enable Java for this app. All right. Then we're going to create our application. And we need to give it a name that's unique. So let's call this Vaadin CRM tutorial. Okay. And then let's create a add-on to use Postgres. So Heroku add-ons, create, Heroku, PostgreSQL, and we need to pass in the app name, which in our case is Vaadin CRM tutorial. All right, that takes care of that. So now we're ready to actually deploy this. So we'll type in Heroku, deploy, jar. Then we find our jar in the target. So it'll be the Flow CRM tutorial snapshot jar. Then again, we pass in the app name. So Vaadin CRM tutorial. And then we wait for this to complete. It'll take a while when it sends over the application. Right, and you can see that we are now deployed to Heroku at this address, so we can go to our browser and navigate to the URL. The first time it starts, it'll take a while for the app to actually boot up. And one thing to note with Heroku is that they do turn off their servers after a little while of inactivity, and at least once per day. So this might not be the kind of perfect solution for a production deployment, but it's really great for an easy way to get started. So we have our app up and running. So we'll type in user pass, login, and sure enough, here is our application running on the internet.